exercise question 432. Find the values of k for each of the following quadratic equations so that they have two equal roots. And then there are two sub questions. So first we have to understand when do two equal roots. These are going to be quadratic expressions with a values as coefficient of x square, b value as coefficient of x, and c value as the constant. And the quadratic equation is in the format x equal to minus b plus or minus, because we are going to get two roots. A quadratic equation have maximum power equal to 2. So we are going to get like two separate roots. And these separate roots are once by addition, once by subtraction. So whatever is after this is going to get us two separate roots, because this part is going to be added after taking square root, is added or subtracted. Now, what will happen if this part, which I have shaded here, b square minus 4ac, is equal to 0? Let's assume that for a while. If this part, which is shaded here, is 0, then square root of 0 will be 0. So even if you add or even if you subtract, since you're adding and subtracting 0, so the two roots are going to be exactly identical. And that is what exactly they have asked. So you are going to get two equal roots. And this will happen when this shaded part is exactly 0, because there is nothing to add and subtract. So there is nothing to give you two separate values. Or in other words, even if you get two roots, they are going to be exactly same or identical. And so whenever they ask you two equal roots, so that means you have to simply say the discriminant, which is the shaded value, is b square minus 4ac is 0. So then only you will get equal roots. So let's take this first expression, 2x square plus kx plus 3 equal to 0. Compare that with ax square plus b plus c, and you will get a, which is the coefficient of x square, b is the coefficient of x, and c is the constant term. In that case, we will evaluate this delta or minus 4ac and equate it to 0, because we are looking for specific situation where the roots are going to be equal. And that happens only when this b square minus 4ac becomes 0. It's a matter of substitution. So b is actually k. 4 times a times c, a is 2, c is 3. So upon simplification, you get k square minus 24 equal to 0. Let us transfer this 24 on the other side, and we will get k square equal to 24. Let's take the square root of 24. 24 is not a perfect square, but we can split it as 4 times 6. So square root of 4, well, yes, it's possible too. And square root of 6, it's not possible. It's not a perfect square. So we'll keep it under the square root sign. So the final answer is going to be 2 root 6. So when k is equal to 2 root 6, we will get the two roots which are same. So it's the same root repeated again and again. Let's take the second sub question. Well, let's write it down. And we'll try to bring it in the standard quadratic form, because eventually we are going to evaluate b square minus 4ac. For that purpose, we require the value of a, b, and c. So let's try to make it as simple as possible. Kx times x is kx square. Kx times negative 2 is negative 2kx, and plus 6 as it is. Now it's in the standard form. We have something x square, something x, and then constant. Now we can write down a as k, which is the coefficient of x square. Negative 2k is actually b, because that's the coefficient of x term, and the constant term is simply c. Let us evaluate b square minus 4ac equal to as and equate it to 0. It's a matter of substitution. B is negative 2k square. 4 times a is k, and c is 6. Now remember, square of a negative number is still positive. So negative 2k, the whole bracket square, is as if like you are squaring 2k square. So this is 4 times k square, and this will be negative 24k. I can get rid of 4 because it's common in both. I can do that because on the right hand side anyway we have 0. So k square minus 6k equal to 0. We will factorize that k minus 6 equal to 0. So either k is equal to 0 or k minus 6 equal to 0. And so that will give us two values of k, either 0 or 6. And that will be your final answer.